Hello, this is a video of my hydraulic system doing a 2 Hertz sine test. You can see in the picture I've got a hydraulic actuator going back and forth. The amplitude is 1/2 of an inch, or about 12.5 millimeters, and the frequency is 2 Hertz. And I go into graphing mode. I can record this information. The information that you'll see will be gathered in 1/4 millisecond increments, or 4,000 samples a second. That's 4,000 samples a second. It's being captured over 100 megabit per second Ethernet. And then I can grab this information. Now I can put my cursor, oops, still gathering information. Okay, now I can put my cursor wherever I wish to be. And over here I have the target position and the actual positions. Let me just blow that up a little bit here. And you can see that I'm off by 2 thousandths at that point. I have the target and actual velocity and the control output and voltage and status bits. And I can move my cursor along, and you can see the time up here is changing at 1/4 millisecond increments. And I can go back and forth through my plot here, gather all this information. So most of this information is being buffered on the motion controller, and the RMC then can relay it back up to the PC over Ethernet. So this is 2 Hertz. Now let's go back and increase the frequency. What I'm going to do is slow down the sample rate to 10 milliseconds and do the trend. Whoops. Gotta change it 10 milliseconds. Okay, now start it. Okay, this is a 10 millisecond trend. And what I'm going to do is change the frequency on the fly. Now it's auto scaling. Okay, now that's because the velocities have to go up quite a bit. So those are scaling. Now I'm going to move it back down to 2 Hertz. And you can see we have a nice logarithmic change. I'm going to stop this. And now, so we can go back through the plot here and see the error has increased a little bit. We're off by about 20 thousandths right now at 50 Hertz. Yeah, let's see, that's about 45 thousandths. Excuse me, at 5 Hertz. So let me blow this up. Oops, it's already blown up. Nope, that's compressed. Okay, to get this information in more resolution, I have to go back to 1/4 millisecond and run the test again. So I'm going to tell it to capture. I'm going to go to 5 Hertz, then go back to 7 Hertz, slowing it back down. I'm going to stop it. Now I should be able to go back in time. Probably wasn't fast enough to get back there. No, that still looks like we are off at 2 Hertz. But in any case, you can see that it's very easy to do a sine wave using our controller. The commands to do this are pretty simple. This is the command that starts it. I've got it set so that the middle position is 4.5 inches and the amplitude is 0.5 inches, so the motion will go between 4 and 5 inches. And then I have 2 Hertz is my starting frequency. The 0 means I'm going to go for an infinite number of cycles, and the start location, it says auto. I've got these choices. I can have it start at the middle of the sine wave at the position peak, the mid-negative, or the negative peak. And right now I've just have it picking the quarter that's easiest to find. And if we wish to, we can save the information in our variable table using a status block. but for this purposes I didn't need it. I can stop the sine wave by just hitting the 5. Now I've hit that, and the see, it stopped. If I go back up here and hit F4 again, we're moving again. And if I click on 6, now it's doing 5 hertz. Now it's back to 2 hertz. That concludes my video.